Dear friends, welcome to the video tutorial on antilogarithms. In this tutorial, we will learn what is antilogarithm, antilog table, antilog calculation using tables, solved examples on antilogarithm, and lastly, exercises. So let's begin with understanding what is antilogarithm. It is the number whose logarithm is a given number. For example, the logarithm of 1000, that is 10 cube, is 3. So the antilogarithm of 3 is 1000. In algebraic notation, if log x equal to y, then antilog of y equals x. Similarly, if log of m equals x, then m is called the antilogarithm of x and is written as m equals antilog of x. One more example, if log 39.2 equals 1.5933, then antilog of 1.5933 equals 39.2. We will study logarithm in more details with a few examples in the next slides. Now let's see relationship of logs and antilogs. Firstly, if f of x equals log of x, then f inverse x equals antilog of x. Also, antilog of x equals 10 to the power x. Secondly, log of x equals y, and following which 10 to the power x equals x. For example, log of 100 equals 2, then 10 to the power 2 equals 100. Now, let's understand antilog table. Antilog table is similar to log table. The only difference is in the first column from left, which ranges from 0.00 to 0.99. Antilog table consists of rows that go from 0.00, 0.01 and up to 0.99. The columns have values 0, 1, 2 up to 9. Beyond the 10 columns, there is another column which known as the mean difference. Tables gives values base to 10. Now let us understand calculation of antilogarithms with a few examples. Find antilogarithm of 2.5463. Now, since antilog of x is 10 to the power x, applying the same property here, we get antilog of 2.5463 equals 10 raised to the power 2.5463. Therefore, it becomes 10 square multiplied by antilog of 0.5463, where 2 is the characteristic and 0.5463 is the mantissa. In the mantissa 0.5463, 0.54 is the value of the row in the antilog table, 6 is the value of the column in the antilog table, and 3 is the column of the mean differences in the antilog table. So let's look into antilog table and find out the respective values. Open the log table and find the number 0.54 in the first column of the table. Now move to the row of 0.54 and stop at the column number 6, as 6 is the next digit after 0.54 in the given number. Make a note of this value obtained at the intersection of row number 0.54 and column number 6. Secondly, in the same row of number 0.54, we will move to the columns of mean differences and look for column headed by 3, as 3 is the next digit after 6 in the given number. Here we obtain 2. Now add both the obtained values, that is 3516 plus 2, which equals to 3518. Therefore antilog of 0.5463 equals 3.518, and combining it with antilog of 2.5463, it results to 351.8. Let us understand it better with taking another example. Calculating antilog of a negative number, that is minus 8.654. Now for negative numbers, use the whole number next to the given number and add and subtract it. It is a commonly used mathematical trick. Therefore antilog of minus 8.654 equals antilog of plus 9 minus 8.654, which results to 0.346. And antilog of 0.346 multiplied by 10 raised to the power 9. Now from the antilog table we will calculate antilog of 0.346. Therefore open the log table and find the number 0.34 in the first column of the table, and move to the row of 0.34 and stop at the column number 6, as 6 is the next digit after 0.34 in the given number. Make a note of this value obtained at the intersection of row number 0.34 and column number 6. Since there is no digit after 0.346, the obtained value is the final value, and we do not need to look in the columns of mean differences. Therefore antilog of 0.346 equals 2.218, and hence antilog of minus 8.654 equals 2.218 multiplied by 10 raised to the power 9. Now let's solve another example by slightly different method. Find antilog of minus 1.9087. So firstly convert minus 1.9087 in bar notation. After conversion we get characteristic of minus 1.9087 equals minus 2, and its mantissa as 0.0913. So from antilog table we will calculate antilog of 0.0913. Find the number 0.09 in the first column of the table and move to the row of 0.09 and stop at the column number 1, as 1 is the next digit after 0.09 in the given number. Make a note of this value obtained at the intersection of row number 0.9, row number 0.09 and column number 1. Secondly, in the same row we will move to the columns of mean differences and look for the column headed by 3, as 3 is the next digit after 1 in the given number. Here we obtain 1. Now add both the obtained values, that is 1233 and 1, which equals to 1234. Now place a decimal point before the 1234 followed by a 0, and you get the number 0.01234. Hence antilog of minus 1.9087 equals 0.01234. Now since you are introduced with the basics of antilogarithms, practice the following questions listed as exercise to master the concept of antilogarithms. Thank you for learning with me. See you in the next tutorial. Have a good day.